Hi, I'm Brian from Simply Brian Enterprises and welcome to my channel. Today I'm going to be taking us to the next step in the setup of the Redabbler, and this is a response to Top Tech Boy's Arduino with Python series lesson 2. Now, Paul did not assign us homework in lesson 2, however, I wanted to do a little bit of a rundown because Paul showed us setting up the Python, Arduino, and Microsoft Visual Studio Code environment in Windows, but we want to set it up in Linux on the Raspberry Pi. So I'm going to walk you through how to do that and how to achieve a parity result so that when we go into lesson 3 and actually start doing homework, we'll have a system that matches what we're being taught in Paul's class. So first thing I'm going to do is I'm going to open up an SSH session into my Pi 4 that's running on the Redabbler. And the reason I'm going to do this over SSH is because I want to make sure that I have the ability to copy and paste some of these commands for efficiency. Took me a while to figure out all the nuances, and it's just easier if I just copy and paste things. So the first thing we're going to do is we're going to come in here and we're just going to do a apt-get update to make sure that we've got the latest apt cache available for package installation. And then we're going to do an update of some specific packages. And this list of packages that I'm going to paste in are prerequisites for building Python and associated modules. So many of these are already installed, some need to be updated. In this case, they should all be updated on my system. But if you're doing with fresh install of Raspbian, you will likely need to install and or update some of these packages. I should make a note that I'm running Debian Bullseye, and the reason I'm running Bullseye as opposed to Buster is because there are some problems that we run into with Python modules if we're running too old of a version. For those of you who don't understand Debian versioning, every version of Debian is named after a Toy Story character, and Debian 10 is named after Buster the dog, and Debian 11 is named after Bullseye, which is of course Woody's horse. So in case you were wondering where they get the names from, that's characters from Toy Story. So again, I've moved up to Raspbian 11 versus Raspbian 10 because we're going to need it when we actually build Python. So the next step we need to do is we need to download and install Python. So I'm going to come over here to the browser, and I'm going to go to python.org, and under downloads, I'm going to click on all releases and scroll down here to Python 3.99. And I'm going to scroll down here to this gzip source tarball, and I'm going to copy this link. Again, this is why I'm doing it through PuTTY, because I'd rather be able to just paste it. So I'm going to go into downloads, and you know what? I don't remember if there's stuff in here, so I'm going to get rid of it. And I'm going to now wget my Python package. And for those of you who are unfamiliar with Linux, .tgz means it is a tar file that has been gzipped. And so that needs to be extracted using the tar command. So I'm going to type tar, which by the way stands for tape archive. It's a very powerful tool that's been around for decades, and we still use it because there's really not a good replacement. And I'm going to use the command X, which is extract. So if I'm creating a tar package, it would be a C. I'm going to use X to extract. Z, because it's a zipped package, tar actually contains a copy of gzip for creating and unpacking gzip files. And V, so I can see what it's doing, that's verbose. And finally F, which is the file name. What file name am I operating on? So I'm going to not mistype it. And I'm going to go in and I'm going to unpack the Python tarball. And now I'm going to go into this directory. Now, I'm not actually going to go through all the steps because it takes a little time and I've already installed everything. But if you're not familiar with compiling things on Linux, there's basically 3 commands you need to run. The first is a /configure. And what that is going to do is it's going to set up environment variables. It's going to look at your system, find the paths to all the compilers and everything. and it's going to spit out what we call a make file. Once the make file, like that, is created, we're just simply going to type make. And the make executes an instruction which says run all the compile commands in the make file. And then once that's done, then we're going to actually install the packages, for which we need to be root because we're installing into system folders. And so I'm going to do a sudo make install. And that's going to run, and it's going to install Python 399. So now let's take a look and see what's installed in the system. So I'm going to do a python -- version. And lo and behold, we see that Python is linked to a version of Python that is 3.9.2, which is not the version we just installed. So the next thing we need to do to protect ourselves from upgrades that we didn't authorize is we need to actually go in and block upgrades from happening in a apt update. So I'm going to pop in this command, and there's a little bit to explain here. I'll try to just be brief with it. Dpkg is listing all of the packages that are installed. Get selections to filter it. Grep Python 3, so we're just looking at packages that match the string of Python 3. And then we're going to run this command called apt-mark, which marks them as hold, which means don't upgrade. And basically I'm just putting this in a loop, and it's telling it to take every package that matches Python 3 and mark it on hold. And I'm going to run this. It's going to run quick because everything is already set to hold. There is a bug in this code because it's sending a null character to the apt-mark command, and that's why you see that no package is found message. It can't find a package called null character. And rather than trying to troubleshoot it, I decided to let it go because it's really not detrimental to what we're trying to do. But this is going to protect us from future updates. It's not going to try to wipe out the Python 3.9.9 that we just installed. So now I'm going to type, instead of Python, I'm going to do Python 3. And what we find is that there's a 3.9.9. We'll do a quick which here so you can see the difference. So I'm going to do which Python, user bin Python. That's where the factory installed that came with Raspbian. And I'm going to do a Python 3, which shows it's in user local bin. So in Linux, user bin is more for system utilities. User local bin is more for user add-ons and software installed later. And of course, we want to use the software that we've installed later. Thankfully, Python 3 is symlinked to that. So the next step then is to go into our directory and set up our virtual environment. So I'm going to go tilde. So first of all, if you're not familiar with Linux, tilde is your home directory. And I have created a subtree called projects. And in this, I'm going to do an AL so you can see that a little better. You can see that we have Top Tech Boy Python Arduino, Top Tech Boy Raspberry Pi. Now I haven't started with the Raspberry Pi ones yet, so I'm going to go through creating that actually. Here, I'll just go Pi, arp star, get rid of everything, and we'll just kind of start from scratch. So once I have my projects directory, this is where I'm going to create all of my projects for this class. First thing I'm going to do is I'm going to make a Python folder. And the reason I'm going to create a Python folder is just to distinguish my classroom project code from the binaries and libraries that Python is using. And now I'm going to change it to this Python directory. Now I'm actually going to create my virtual environment. So I'm going to do Python 3-m-v-n-v. And I'm going to name this ttb Raspi. I want something short but descriptive, so that way when I change into that environment, it's going to give me a prompt that's easily understood of which environment I'm operating in. And that'll, of course, take a second. Or 3. There we go. So now I'm going to back up to my parent directory. And now I'm actually going to test out that environment, make sure that the environment is available and stable. So in order to do that, I'm going to type source. Wait, what does source mean? Can I just run the script or do I need to source it? And in this case, I need to source it. I'm going to do a quick demo as to why, but we'll move on here. Python, ttb, so there's my directory where I installed my venv, bin, and there's a shell script called activate. So I'm doing bin python ttb raspberry bin activate, and just like that, I am now in the virtual environment ttp raspi. And just to test that we're there, I'm going to type Python. Remember, up here, it pulled up a version of 3.92, and here it's going to pull up 3.99. So we know that the virtual environment is created. We're linked in okay. Everything's going to be okay. But there's one thing I don't like, and that is the ugliness of this prompt. It is using what in the 16-bit color palette, or the 16 color palette, would be known as low intensity white. And I want something a little more interesting than that. So I'm going to type deactivate, which sourcing the activate file brings you into the virtual environment. Deactivate is a function that gets loaded into memory that takes you back out, and it restores all your system variables back to normal. So if I do a python-f version here, we'll see that I need to type a little cleaner. Now we're in Python 3.92 again, so I have to make sure that outside of that environment I'm using Python 3. So that's just a quick note. We've unset all the variables. We're back to normal. So now I actually want to make a change to that file. And what I'm going to do is I'm going to use a command called sed, which is a parsing and replace, basically a search and replace parser type script. And I'm going to put some color into the file. And so what I'm doing here, I won't try to explain this too much, but -i means hunt down the file and replace. I'm looking for this variable called ps1. That is a bash variable for what my command prompt looks like. And I'm putting in this kind of funky looking color string here. This right here is my actual color. So 0, 1 is high intensity versus low intensity. So if you know anything about the 16 color palette that's been in use for decades, there's 16 colors, there's 8 that are low intensity, 8 that are high intensity. We're going to choose from the 8 high intensity, and the number we're going to choose is 33, and you'll see why in just a second. I'm not going to give it all away. So now I'm going to go and hunt down that script, activate, and now we're going to try again. I'm going to source Python, ttb, bin, activate. And just like that, now we have this very nice descriptive bright yellow as opposed to the dull gray. And for me personally, I appreciate that. I'm going to post all of these things I'm going to paste in. I'm going to post down below so you can copy and paste and tinker with as well. But you can play with this value right here, this 33. This is our color value. So 31 is red, 32 is green, 33 is yellow. You can kind of play around, and of course there's documentation online as to what each of them does. So now I'm going to go again and deactivate, and I'm back to my standard prompt. So let's take a quick second and talk about sourcing a file versus executing a file. I'm going to create a very quick little script here. If I can do this without screwing it up too bad. And this is just a simple bash script. And what I'm going to do is I'm going to set a variable to 10, and then I'm going to echo my variable is just like that. And I'm going to model x set. So now I type set, and my var is 10. So I've set the variable to 10, and now it echoes that my variable is 10. Well, what I want to do is I want to set this globally. So I'm going to set my var as 5, and I'm going to echo to make sure it set that as 5. And it did. And now I'm going to run the script again. And now I'm going to change my var to 10. I'll just hit the up button. Well, wait a second. I'd set it to 5, then I ran the script which said it set it to 10, but now it's 5. Why did it do that? Well, there's a reason. This script is a shell script, and when it runs, it launches a new session of bash, runs the variable, outputs the contents in that bash shell, but then when the script exits, it tears down that bash session. So it doesn't carry over into the rest of my session. So if I wanted to use a script like this to set my var to 10 persistently, I would need to do something a little bit different. I would basically need to go in and type each of these commands one by one. Well, guess what source does? Source says I'm going to take a string of text in a file and I'm going to literally type each command. So now instead of running this, I'm going to source it. So we saw that my var was 5. Now I'm going to source this. It says my var is 10. Let's see what my var is set to in my shell. And now it's set to 10. So that's why when we execute that Python activate script, we need to use source as opposed to running it directly, because we want the contents of that file to apply to our existing bash shell. We don't want to create a new bash shell, set everything, and then tear it back down again. That would be completely unproductive for our purposes. So finally, after I have that set up, we are going to do our final steps, which is install the Arduino IDE as well as Microsoft Visual Studio Code. Yes, you can install Microsoft Visual Studio Code right on your Raspbian Debian Pi, and we will do just that. So I'm going to do a sudo apt-get install Arduino, which is the package, the master package name of the Arduino IDE and all of its subordinates. And then Visual Studio Code is simply code. So we're going to do an apt-get install Arduino and code. You can install multiple packages by just space delimiting them. And I'm going to hit enter, and of course I already have them installed. If you don't have them installed, it's going to present you with a big list. Hit yes, let it install. It'll churn for a bit, and we're on our way. So now our final step is I'm going to pull up my console here of the Raspbian Pi. Keep calling it Raspbian Pi. Raspbian is the OS, Raspberry Pi is the actual piece of hardware. And once again, I'm going to use my K400 keyboard to manipulate the console. It went to sleep there, that's why you saw the color bars. And I'm going to move this mouse out of the way. And now I'm going to come in here, and you can see my icon changed. I got to go back and fix that at some point. But now I've got the Arduino IDE. I've got Visual Studio Code. Now you're right on par with where Paul left off in lesson 2. We have Visual Studio Code installed. We have Arduino installed. You can go through this Visual Studio Code, and setting it up is very similar to how Paul set up the environment variables, and you can see I changed the color and everything. And now we're ready to go. Now we're ready to jump into lesson 3 because our environment is all set up and running. Hope you enjoyed this video. I promise as we get into the homework, these are going to get shorter. I just wanted to do a good demonstration of everything that I've had to do to make this environment work. The Raspberry Pi and Arduino were really powerful stuff, really exciting stuff, and I'm really looking forward to doing these lessons on the Redabbler and everything that I've set up so far. So I appreciate you watching. Thank you again. It's Brian from Simply Brian Enterprises, and I will catch you next time. Thank you for watching.